Hello chemistry students, I wanted to just make a really quick video to give a little overview on some notes in addition to the Khan Academy video I've already posted on Canvas. So an isotope, as you have hopefully already learned, is just an element with a differing number of neutrons. So when you were in class, we went over some notes on neutrons and protons and electrons, and a neutron we know comes from the atomic mass if we subtract the atomic number. We know that we can never change the number of protons because that creates a different element. We know if we change the electrons, we get a charge. And if we change the number of neutrons, we get what's called an isotope. So looking here, carbon has 3 different isotopes. We could have carbon 12, which means it has a mass of 12. Carbon 13, showing it has a mass of 13. Or carbon 14, showing it has a mass of 14. Notice that all of these carbons all have 6 protons because we know we can't change that atomic number of 6 because it'll change our atom, but we can change our number of neutrons, which makes the nucleus heavier or lighter depending on the number of neutrons. And again, that's called an isotope. Alrighty, let me change. A valence electron. I went over this a little bit with my general chemistry students, but not at all with my honors chemistry students. So if you have questions on this, be sure to ask. So a valence electron is an outer shell electron that is associated with an atom, and it can participate in the formation of a chemical bond. So we talked about how to draw orbital diagrams in class. And now an orbital diagram is when you have 2 orbitals, 2 electrons in the first orbital, 8 in the second, and 18 in the third. Okay, and I'm going to show you again how to draw that. So let me go to the whiteboard in the back of my room here. Alrighty, so let's pretend we are looking at fluorine. Okay, and we know that, oh no, I forgot that my camera's not switched. So I'm just going to draw F like this, and that appears right, correct? Okay, I'm going to have to draw backwards. F. We know that fluorine has how many protons? 9. And if it doesn't have a charge, which this fluorine doesn't, how many electrons is it going to have? Again, it's going to have 9. So our rules for electron orbitals is 2, 8, 6, 18, or 2, 8, 8 is easier for us to remember. So we're going to draw our first orbital. And in that orbital, we know it can hold how many electrons? 1, 2. However, we need to have 9 electrons total. So we need to draw another orbital. In our second orbital, we can hold up to 8 electrons. So we're going to draw, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that we have a total of 9 electrons in this orbital. And this is an orbital diagram. So I just told you that valence electrons are our very outer electrons that can bond. So our valence electrons are our electrons in this very outer shell. So in this example of fluorine, we have 1, 2, 3, 4, 5, 6, 7 valence electrons. Let's do another one and look at magnesium. This will be a harder one for me to draw backwards. Is that right? Oh, yes. Okay, magnesium. So take a look at magnesium on your periodic table, which you all should have. If not, go ahead and look one up online. Magnesium has 12 protons, I believe, off the top of my head. So it has 12 electrons as well. So how many electrons are we going to put in this first outer shell? 1, 2. How many can fit in our next shell? 8. 1, 2, 3, 4, 5, 6, 7, 8. So far we have 10 total, but we need 12. So we need to add a third orbital with 2 more electrons. So how many valence electrons do I have now? I would have 2 valence electrons because I have 2 electrons in my outer shell. These are the electrons that can participate in bonding. Please notice that when I drew magnesium, I didn't go like this and then put my electrons like this. Notice they are perfectly spaced next to one another around the diagram. Alrighty, let me shrink myself back up here and do a couple more notes before we're done with this little video. Okay, so again, our orbitals can hold 2 electrons in the first, 8 in the second, and 18 in the third. And remember that Niels Bohr is the one that came up with this planetary model. Okay, and we've already talked about a chemical bond. We know that a chemical bond is the force that holds 2 atoms together. And remember, those valence electrons are what are the things that can form bonds. The last thing I want to talk about briefly is just what an ion is. Okay, so an ion is a charged atom. And it's causing a charge by gaining or losing electrons. We talked about ions in class, and I gave you some examples of how to calculate how many electrons are in an ion. So if we look at Na+, Na+1, if there's nothing there, it automatically assumes it's a plus. So it's an ion because there's some sort of charge. Anything with a charge is always an ion. So sodium, Na, has 11 protons. If it has a positive charge, it would have 10 electrons. I want you to go hard and try out Cl-3 and K+2 on your own, and let me know if you struggle figuring out how many electrons are in there. So I'll give you 1 second to figure that out. I believe off the top of my head, I don't have my periodic table in front of me, that chlorine has 17 protons. So if it had a -3 charge, it would have 20 electrons. Ooh, potassium, I don't know off the top of my head. Let me search for the periodic table. Oh, I found one in this pile of stuff. Potassium normally has 19 protons, so if it had a +2 charge, it would have 17 electrons. Your homework for tonight will focus on this and identifying those things, so let me know if you have any questions. Thank you.